This is lesson 5, example 2. In this problem, this is a more than problem. In this problem, we are comparing the non-commercial vehicles on the highway to the commercial vehicles on the highway in the month of September. So let's go ahead and highlight that information. There's our ratio language. For every 14 non-commercial vehicles, there were 5 commercial vehicles. In these more than problems, they always give you a number that tells you that there is more of this than this. So that is important. We have 108 more non-commercial vehicles than commercial vehicles in the month of September. We're trying to find out exactly how many of each type. So how many of each type of vehicle in September. So in this problem, we'll go ahead. We are comparing non-commercial. We'll let NC represent non-commercial vehicles, and we are comparing it to the commercial vehicles. Our ratio is 14 non-commercial. For every 14 non-commercial, there are 5 commercial vehicles. So we'll go ahead and set up our tape diagram. We'll let NC again represent non-commercial, and C represent commercial. And I'll go ahead and get that tape diagram set up. Okay, so we have our tape diagram all created. We have 14 pieces to represent the non-commercial. We have 5 pieces to represent the commercial vehicles. It's important to try to make those equal size pieces too. All right, so we're looking at the more than pieces. You can see I have 1 here and 1 here, 1 and 1, 1 and 1, 1 and 1, and 1 and 1. So these pieces right here represent my more than pieces, my more than. And if we look up in our problem, it says that those more than pieces are equal to 108. So these pieces right here equal 108 vehicles. In order to find the value of each of these 9 pieces that equal 108, and what is the value of one of those, we can set up a division problem here, and we can do 108 divided by those 9 extra pieces that we have. Okay, we have 14, take away 5 is 9. That's another way that you can get your thing other than matching them up. When we divide through, we get an answer that is 12. What does that 12 mean? It means that each of these pieces has a value of 12. Every piece in this tape diagram has a value of 12, as well as every piece in this tape diagram has a value of 12. So we have each of those with a value of 12. And each of these has a value of 12 also. Okay? So in order to answer a question, how many of each type of vehicle use the highways in September, we have a total of 14 pieces, each one having a value of 12. So I have 14 times 12, and that will give me my answer of 168. And down on this one, I have 5 pieces. Each piece has a value of 12, and so I have a total of 60 commercial vehicles in the month of September on the highway. Well, we can check our math, and we can come over here and just, we know that we have 168 commercial. We know we have 60 commercial vehicles. And we're told up here that there should be 108 more of these. So when I subtract, do I get 108? Yes. So to answer a question, how many were in the month of September? We had 168 non-commercial vehicles and 60 commercial vehicles on the highway in the month of September. And that is how you solve a more than type problem. First of all, make your tape diagram. Then identify the more than pieces. Make sure you're looking at what is more than. In this case, it was our non-commercial vehicles that were more than. And find the value of each of those more than pieces. And then apply that to every piece in your tape diagram, and you'll be able to find out how many of each type of vehicle were used in the month of September. Hope this helps. Lesson 5. example 2.